Welcome to the seventh and final standard of quarter one. Congratulations. It's been a crazy quarter with remote learning, and I'm very impressed with almost all of your grades and effort so far. So keep up the good work. All right, this last standard is just finding perimeter and area of shapes, which seems too easy for a high school geometry class. You guys have been doing this since grade school. For example, here's a rectangle that's 4 by 2. So the area would be 8, 2 times 4, length times width. The perimeter, which I'm calling P, would be 12. If one side is 4, the opposite side's 4. If one side's 2, the opposite side's 2. And perimeter is just adding up all the sides of the shape. So there you go. Easy peasy, right? So unfortunately, it's not going to be that easy. What's going to happen is you're not going to be given the lengths of the sides. What you're going to be given are the coordinates of the corners of the shape. And then you'll have to figure out what the lengths of the sides are. For example, this coordinate might be 6, 5, and this one 6, 7. Here's a 2, 7, and here's a 2, 5. And it's the exact same size rectangle as I just gave you. What is the distance going straight up and down between 5 and 7? 2. What's the distance straight up and down over here on this side between 5 and 7? The same thing, 2. How about across? You're starting at 2 across and you're going all the way to 6 across. 1, 2, 3, 4 more spaces from 2 to 6. All right, so you see it's the exact same rectangle, but instead of giving you the 2's and the 4's for the lengths, you have to figure them out from the coordinates, which really is pretty easy too, as long as the shape has sides that are going straight across or straight up and down. You can just count how far it is from one number to the next. So you may be saying, all right, give us the test, this is easy. Unfortunately, not all of your shapes are going to be straight across or straight up and down. They might be diagonal. So you might have a rectangle that looks like this. All right, and that is an ugly looking rectangle, but I'm not an artist yet. If this is your rectangle, let's just say this point right here, 1, 2, 3, 4, 5, we'll say that's 5, 2, and it's not to scale, but I'm going to say this is 8, 6. All right, let's take it one side at a time. How are you going to find the length from 5, 2 to 8, 6, from here to here? That's the objective of the day, finding the length of a diagonal. Now we're getting into some potentially new math if you haven't seen this before. You can't just count. If this is on a piece of graph paper, the grids don't go diagonally. They go straight across and straight up and down. So there's nothing really to count from one space to the next. If you try and say this length is 3 because from 5 to 8 is 3, that would be incorrect. The length that is 3 is straight across 3. If you try and say this length is 4 from 2 to 6, that would be incorrect because 2 to 6 is going straight up and down. The length of 4 is actually right here. So to get from this point to that point, you're going across 3 and up 4, which is nice to know, but that doesn't specifically tell us what the length of this diagonal line is, which is what we need to know because that's the side of the rectangle. You can't find perimeter and area if you don't know the length of the side of a rectangle. So why even use these? Why are the 3 and the 4 important, you might be thinking? And I will tell you now why. It's because to find the length of a diagonal, you have to use Pythagorean theorem. One of my favorites. Maybe you've heard of this before. Pythagorean theorem. What Pythagorean theorem says is that if you have a right triangle, well, we don't have a right triangle, we have a rectangle, but we just made ourselves a little right triangle. We went straight across and straight up and down. That makes a right angle. We just built the two legs, the two straight sides of the right triangle, and the diagonal side that we're trying to find is the hypotenuse. It's the diagonal side of the triangle. Pythagorean theorem says you square the two straight sides and add them together, and they equal the square of the diagonal side. So what did I just say? I said square the two straight sides, squaring a number. So 3 squared and 4 squared. That's 9 and 16. 3 squared is 9, 4 squared is 16. Pythagorean theorem says after you square those sides, I probably shouldn't have shifted the board. After you square those sides, you add them together. And what do you get? You get 25. 9 plus 16 is 25. So is the length of this side 25? No. If you square the length of this side, you'll get 25. So what number do you have to square to get to 25? Well, to know for sure, you have to unsquare 25. And there's a technical name for unsquaring a number. It's called taking the square root. And the square root of 25, that's right, is 5. So 3 squared plus 4 squared equals 5 squared. But the length of that diagonal is 5. 3, 4, 5 triangle. That's how you're going to have to do these problems. All right, you're going to have lots of problems in this week where you're trying to find the length of a diagonal line just giving the coordinates of the end of the line. Let me do one more for you here. Let me erase my coordinate plane so that it doesn't confuse you that I'm out of scale here. I'll do this point right here. Let's say this point is -7, +7. All right, so this point's -7, +7. And we want to know the length of the bottom of our rectangle. It's not going to be 4. I'm not using the same size rectangle as the example in the beginning. Well, you got to draw your right triangle. You have to use Pythagorean theorem. So you have to go straight down and straight over to get your right angle. Now you have a right triangle, you can use Pythagorean theorem. So what are the lengths of the two straight sides? How far across is it from -7 all the way over to 5? That's the x coordinates. The x coordinates of your points are the ones that tell you the distance from side to side. So from -7 all the way to 5, well, it takes 7 spaces to get to 0, and then another 5 spaces to get to 5. That's 12 spaces. How about from 2 up to 7? From 2 up to 7, that's 5. There you go. Once you have your two straight sides of your triangle that you created, which is basically just like figuring out slope, the slope of this line from one point to the next would be 5/12. So you guys have done this before. You just didn't realize you were making a right triangle maybe, but you've done this to figure out the slope of that line. You're doing the same thing here. What's the rise? What's the run from one point to the next? It's 5/12 would be your slope. We don't put it in a fraction for Pythagorean theorem though. We keep them separate and we square those two numbers. So 5 squared plus 12 squared, that's 25 plus 144, which equals 169. So you have to take the square root of that number now, which may not pop right into your head because it's more than 12, and most people only memorize their times tables up to 12, but it's one more than 12. It's 13. The square root of 169 is 13, so the length of this diagonal or that side of the rectangle was 13. We had a 5 and a 13. Now you can figure out the area and the perimeter because rectangles, the opposite sides are the same. So this one's 5, this one's 13. That would make the area equal to 5 times 13, which is 65. It would make the perimeter equal to 26 plus 10, 36. All right, so we're finally back to that very first example I gave you with the rectangle that was 2 and 4. When you're given the lengths of the sides, it's easy to figure out area and perimeter. You're not going to be given the lengths of the sides. You're going to have to figure them out and you're going to have diagonal lines, so you're going to have to use Pythagorean theorem, which isn't too bad. I think you guys will do good on this one.